From planning your shipments to network routes to visibility into your shipments and cargo conditions while on the go. You need visibility every step of the way and the ability to be flexible from planning to execution. Order fulfillment and order to cash processes are at the heart of every business in every industry. You need to be able to seamlessly manage orders, transportation, global trade, and warehousing processes while leveraging sustainability and adapting to business disruptions and changes in the supply chain. With all the challenges in order fulfillment, as well as increasing pressure from competition, we know that speed, with PPC, is the name of the game. That is why leveraging innovation, particularly AI and machine learning, can make an impact in driving efficiencies in your logistics process. Within Oracle's logistics solutions, you can leverage AI to drive efficiencies across your end-to-end order fulfillment process. Whether it's providing transit time predictions, finding the best carrier option at the right cost, to quickly respond to disruption, or when offering excellent customer service. I've highlighted some logistics and order management use cases that are available now and in the near term. Let's now focus on the first one here, on shipment transit time predictions, and I will go over the rest in a little bit. What happens with shipment ETAs, or estimated time of arrival, is that since they come from carrier and third-party vendors, they are not sufficiently accurate, and they are also not received in a timely manner. What is currently being done today is that companies rely heavily on carriers' coded shipment times, and there's no streamlined process to predict these ETAs. Leveraging Oracle AI in transportation management will provide customers with more accurate ETA predictions and help identify at-risk shipments so companies can take action and mitigate risk. We've also been working with our customers, and so far they are reporting a 64 to 93% prediction accuracy, leading to more on-time deliveries, reducing costs, and higher customer satisfaction. So now I'm curious, I'm sure we're all curious, so I'd like to turn you over to my colleague, Jared Santos-Silva, who will tell you more about how this all works.
Within OTN, we've enabled machine learning models, as Sean was saying, for ETA prediction. And we've done this at two separate times. So the first is predicting ETAs at the time of planning, and then the second is predicting ETAs at the time of shipment execution, or while the shipment is en route. Why really is this important to you? Joan was kind of alluding to this, but when it comes to predicting ETAs during the planning process, it means that you have this ability up front to know that something is going to potentially be delayed or miss a due date further down in your supply chain or to your customers. It lets you then make decisions on routing, carriers, equipment before it's too late. And as you know, once a shipment starts moving, it's really difficult in many cases to change these types of elements. You can't just, midstream change a carrier or a mode or something like that. So being able to have these predictions up front, just after the order has been planned into the shipment, allows you to make these changes. This was an experience I had as a planner in my past where I was responsible for moving cargo across the water, and many times I would have opted to take a different route, mode, or carrier had I known that realistically, for example, my voyage schedules were really very far off and that I wasn't going to make a ton of space. And now, on the other hand, that's the planning with in-transit ETA predictions. This serves as an input to better inform customers' entire supply chain, as well as their customers downstream. And on the transportation side, in-transit ETA prediction also helps ensure that multi-leg moves, so when we think about having a ocean gray, that sort of thing, make sure that these stay in sync and costly expenses such as detention, demurrage, what have you, are avoided. On the slide that I'm showing, you can see a few highlights to our approach. So first off, it's a no-code approach. So there's no need for data scientists in order to get these machine learning models up and going in your OTM or Oracle Transportation Management environment. By default, we have over 160 attributes, shipment attributes, that are taken into consideration. And these can be further specialized by the user, by the use case, by the model, what have you. You can also apply custom environmental factors to the models to help bolster the attributes that you're using when doing training and software. Models can automatically be retrained, so you avoid that model drift scenario where it kind of gets out of date. So as you're getting new shipments being planned, the models can use that data so that they stay up to date, current, so you can avoid model drift. And then finally, we've also enabled analytics for the models. So you can monitor accuracy and performance and identify risky lanes by comparing predicted and planned and actual transit times side by side. So that's a little bit of an overview of what we have available when it comes to ETA predictions within OTM. What I want to do now is I'm going to take you into the application. So I'm going to bring up, just for a moment here, we've got a browser. In the browser, you can see that we are in the application. This is, again, Oracle Transportation Management. And what you're seeing on the screen is what we call a workbench. And a workbench is simply a way of having multiple objects all at once in a single view. So you're not having to go in and out of different panes, that sort of thing, or out of different windows, rather, in order to see the information that you need. In the top left, what you can see is we have our orders at the top. We've got shipments that are related to the orders at the bottom, and then we've got a map over here. What we're looking at in the top left when it comes to these two orders is that we've got two orders that have the exact same source and destination for these two orders are the same. You can see where Incoterms are the same. When we look at our early pickup date, late delivery dates, our promise dates in the orders, these are also the same as well. So two identical orders are in our workbench at present. However, I'm sure you can see right immediately is that we have an issue more than likely with one because we've got this flashing red exclamation point. And this flashing red exclamation point is telling me that, hey, there's a problem with this order, it's likely going to be late. So if we look at the related shipments just below, so when I have this order selected, these related shipments are the ones that are responsible for getting it from Hong Kong to our Denver plant. So we can see we've got an ocean move that's going from Hong Kong to Long Beach, and then we've got a gray move on the inland side that goes from Long Beach into Denver. And what we can see is we've got our ETA and ETA, which, as this is an ocean shipment, it's probably based off a voyage schedule. But then we also have a machine learning based ETA. Same with planned transit time and machine learning based transit time. So these two, the ML, ETA, and transit time, I'm using our embedded models in order to predict realistically what we think that ETA and transit time will be. So it's not just using the voyage schedule, it's using what it knows about our shipment history and things that have happened in the past to make this prediction. What we can see is when we're looking at this ML ETA, it's showing for the 17th of October. And when we look at our promise dates on our order, we promised this order by October 14th. So that's why we have this flashing red icon here in the top. Now, if I come to the second order, or rather the first in the list, we don't have that. So why is that? If we come up here and I select this one, then I can see that instead of going through, I don't know if I called it out for a second, let me just make sure I call it out, but this one's going through the Port of Long Beach. But going up to this other one, we look at going through the Port of Houston, and we can see that machine learning predicted ETA is October 8th, which is within our delivery date window, our promise dates. So this one doesn't have that icon. And again, this is an example of using the ETA prediction while at the time of planning or just after the time of planning. So what happened here? As I mentioned when we were looking at the slide, this is where the planner was able to make a decision and say, hey, I'm not going to take this through Long Beach. I'm going to take this through Port of Houston. They were able to do that within OTM using an action. So we can take an action here to show routing options. And then we have our routing options that we can see. So the original one, Hong Kong to Long Beach, we can see here. Again, this is vessel and then drayage. Then we have other options. So going through Houston, for example. This one's going with rail. Again, another one through Houston, this one with drayage. So we're able to look and evaluate our other options and make an alternate decision before it's too late. Now that is a look at the planning ETA. So now what I want to show you is the in-transit prediction. So for this one, what I'm going to do is we're going to say that let's pretend that our shipment has started moving. So the container's been loaded on board and we are about to depart discharge from the Port of Oregon. So what I'm going to do to illustrate is I'm going to add a tracking event. So this is something that could come in from a real-time visibility provider, some of the carriers, whoever. And again, what I'm showing you is an example where we're looking at ocean, but of course this is mode agnostic. So these models will work for your LTL, your truckload, any mode that you're running currently in your business. So in this case, I'm simulating adding an event to the shipment. So we're just going to say that the carrier told us that we departed. We departed on the 2nd from the Port of Hong Kong. And then we're going to have a lat long in there. So this is just kind of giving us that position of that shipment. So I've added this first event to it. Go ahead and add a second event. So I'm just going to copy it over. Just so that we're saying, okay, well, we left the port, but now we're also moving across the water, right? So this is to illustrate that. So I'll just modify our date and time stamp here. Let's say, well, 10 days later. Of course, the lat long needs to change, so one. And so this kind of simulates going in and adding those events. Now, what I'm going to do is, now that we have these events on there, I'll show you if I change my view up in the top right, you can see these are those two events that we just added. So on the shipment, I'm going to take an action that says predict ETA. And for this, I'm going to select the model that I want to run, and I'm going to click to perform the prediction. Okay? Now, in the previous example with planning, it should be noted that this is something I'm showing you just so you kind of get that behind-the-scenes look. But this is certainly something that can be done automatically within Oracle Transportation Management, so that you're not actually taking this action. But I wanted you to see that at any point it can be run manually, just as we've done taking that quick click shipment. So to explain again what is happening in kind of that visualization, if you look at the map down here, each of these little breadcrumbs represents an event. So as the shipment's moving across the water, we're getting a ping, we're getting a ping, we're getting a ping. With each and every one of these pings or events, this is event number 23, we added 1 and 2. With each of these, we're seeing the ability for OTM to go in and predict that transit time as well as that ETA. So we have what's come in. As it gets closer to the destination, of course, our prediction reliability is going to increase. So you can see we go from 70 to maybe 82% as we're getting closer, and then eventually we get to something that's a very high confidence level in the reliability. What's interesting here, something else that I want to point out, is that when you get to a certain prediction reliability confidence, which is again confidence that you could define within your own deployment of Oracle Transportation Management, you could also have OTM execute some sort of workflow for you. So in this example, one that I like to provide is that if the shipment is coming across the water and eventually we get to 95% prediction reliability, what we might want to do at this point is say, okay, we're quite confident that this is going to be the ETA. Go ahead and have OTM automatically send out a tender to our inland dray carrier. Make sure that we've got those resources secured so that they know that we need that capacity and they'll be ready to go as soon as this hits the port. Again, another way of making sure that we're avoiding detention to merge when you've got these kind of like sort of scenarios.